When stoichiometry problems are given in molecules or atoms, it can be confusing to know exactly where to start. In this video, I'm going to show you how those problems fit into the same methods that we've already learned. Before we get into some examples though, a reminder of the steps. So stoic, the first step being that we need a balanced chemical equation because everything hinges off of this balanced chemical equation. We then need to take our known value from our problem and convert it into moles, because then we need to use a mole ratio to find the moles of our unknown value, and finally convert back the unknown value into the required units of the problem. If you follow these steps in every single stoichiometry problem that you do, you should always theoretically come out with the right answer. Let's just then jump right into an example. So in this example, we have magnesium nitride reacting with water to form magnesium hydroxide and ammonia. How many molecules of water are required to react with 2.3 moles of magnesium nitride? So let's go in, highlight what we're looking for. So we want to know how many molecules of water are required. And what we're given that it's reacting with 2.3 moles of magnesium nitride. All right, now that we've done that, we want to come up with a balanced chemical equation. So let's start there. We've got magnesium nitride, so we're going to go Mg3N2 is reacting with water, and it's forming magnesium hydroxide, so MgOH2, and ammonia, which is NH3. Now, the easiest way to balance from here, this is not a balancing video, but let's balance the magnesiums first with a 3 there, and the nitrogens with a 2 there. And then if we take a look, we got 6 and another 6. So we probably need a 6 here in terms of the hydrogens. Double checking the oxygens, that's perfect. Okay, so we're all balanced. All right, so from here, let's maybe highlight molecules of water. Whoops, we want blue there. So let's highlight that one blue. And then we are reacting with magnesium nitride. So that's that one there. Okay, that's a really nice sort of thing to do as you're working through these problems because it helps highlight what the mole ratio is that we need. Now, we have already got our given value in moles, so we don't need to convert it into moles because we're already there. So we can jump right to our mole ratio, remembering that we put our known values from our balanced chemical equation on one side. So 1 mole of magnesium nitride reacts with 6 moles of water. And then on our left side is the information from our problem. So we got 2.3 moles of magnesium nitride. Since we had it on the top on the left side, we're going to put it on the top here. And then we're trying to figure out how many moles of water we have. Okay, so then we're going to cross multiply. So 1 times x is just x. And then 2.3 times 6 is going to give us 13.8 moles of water. All right, so we got water in moles, but we need it in molecules. So now we need to use Avogadro's number to find the number of molecules. So to do that, we're going to do number of molecules is moles times Avogadro's constant. So we got 13.8 times 6.02 times 10 to the 23. And so that gives us 8.31 times 10 to the 24 molecules of water. And that problem is now done. Now, I do want to note that sometimes the problems here could be worded a little bit differently. They might use the word particles, or they might use formula units instead. And that's okay. Basically, they're all kind of interchangeable, but they don't quite mean the same thing. Particles is an umbrella term that could mean molecules, formula units, atoms, etc. It's a bit more of a general term. Molecules generally refer to covalent compounds. So usually that's the word we use when we talk about covalent compounds. And then formula units is used a bit more often with ionic compounds because it's referring to that lowest ratio of metal to nonmetal. So if I was asking about magnesium nitride in this problem, I might use how many formula units of magnesium nitride are required, for example. So just be aware that the wording could be slightly different, but basically it's mostly interchangeable between each other. Our second example then uses the same reaction. So I'm not going to read that one over, but it's asking how many moles of ammonia are produced when 5.4 times 10 to the 24 molecules of water react with sufficient magnesium nitride. So let's get out our handy dandy highlighter here. We're looking for moles of ammonia. So moles of ammonia are here in our balanced chemical equation. And then we're given 5.4 times 10 to the 24 molecules of water, which is right here in our balanced chemical equation. Now, this problem's set up a little bit differently. We're starting with molecules. So before we can use a mole ratio, we need to convert that into moles. To do that, we're going to do moles is equal to molecules divided by Avogadro's constant. So in this case, we're going to do 5.4 times 10 to the 24 divided by 6.02 times 10 to the 23. And that gives us 8.97009 and so on moles of water. Now, you don't want to round off here because if you do, you're going to end up with rounding off errors. So best to keep that number in your calculator as you continue your calculations. But if for some reason you can't do that, keep at least 4 decimal places after your main number, or 4 non-zero decimal places. So that can be really, really helpful. Now that we've got moles, let's set up our mole ratio. So remember, on the left side, we're going to do the mole ratio from our balanced chemical equation. So we got 6 moles of water produces 2 moles of ammonia. And then on the right, we're setting up our given and our unknown. So because we have moles of water on the top on the left, we're going to put the value we just calculated there for the moles of water on the right on the top. And we're trying to find moles of ammonia here. And then we're going to cross multiply. So 6x is equal to 2 times the 8.97009. And then if we divide both sides by 6 too and do that calculation, that is going to give us an x value of 2.99003, so on. And that is moles of ammonia. We then want to round off for significant digits. So looking back at our problem, we got 2 sig digs here, and all we're doing is multiplying or dividing throughout our problem. So we're going to round off to 2 sig digs here, which makes us 3.0 moles of ammonia. And that is that problem. The last example I have then, we're got the exact same reaction again. This time it's asking how many formula units of magnesium hydroxide. So let's highlight that there. Magnesium hydroxide's here. And you see we're using the word formula units. Basically it means molecules here, but because it's an ionic compound, that's why we're using the word formula units. And then our other given information is that we have 6.7 times 10 to the 24 formula units of magnesium nitride. Okay, so I've highlighted them both. Now this problem requires us to follow all the steps of Stoich. So we're given formula units of magnesium nitride. We need that in moles first. So we're going to do our molecules divided by Avogadro's constant. So that's 6.7 times 10 to the 24. I'm just Gonna write formula units here. I guess I'll write out the whole word. Takes a little bit, but that's okay. And then we're going to divide that by 6.02 times 10 to the 23. So that is going to give us 11.1295, so on, moles of, and that is magnesium nitride. Okay, next step, setting up our mole ratio. We got 1 mole of magnesium nitride and 3 moles of magnesium hydroxide. And then that equals to the 11.1295 moles of the magnesium nitride over X. If we cross multiply, 1X is 3 times 11.1295, which is going to equal to 33.3887, so on. And that is going to be our moles of magnesium hydroxide. Okay, looking back at the problem, we need formula units of magnesium hydroxide. So we need to take these moles now and flip it back into formula units by multiplying by Avogadro's constant. Too many threes here, making it hard to write, but that's okay. So 6.02 times 10 to the 23 times 33 is going to give us, and if we want to round off to sig digs here, we got 2 sig digs, so it's going to be 2.0 times 10 to the 25 formula units of magnesium hydroxide. Okay, so we followed all our steps of Stoich and gotten the correct answer. That was then 3 really great examples of how to go and do stoichiometry when you have given or need to find values in molecules. In the next video, we're going to look at why stoichiometry is always done in moles, even when the problem gives you masses in grams. That video is linked on the screen now and in the description below, so go check it out and we'll see you there.